Hello, welcome to this video on definition of inverse. This is the start of lesson 2B, where we're going to transition from exponential functions to its inverse. So we're going to go ahead and discuss what an inverse is and how to find input-output pairs of inverse functions. You'll be successful in this lesson if you can recognize and understand inverse notation, if you know the definition of inverse notations and functions, and you can find the domain and range of an inverse. So we're going to go ahead and start off with a couple of vocabulary terms and definitions. A function. A function is a relation. It could be a set of ordered pairs. It could be, limited numbers, a finite amount, or unlimited, infinite, for which each input value maps exactly to one output value, and no input values are repeated. An inverse function. If a function consists of the input-output pairs a, b, then the inverse function consists of the input-output pairs b, comma, a. And here is the definition of an inverse. The ordered pairs are going to switch. So a, comma, b for the inverse becomes b, comma, a. X, comma, y becomes y, comma, x. So this means that the inputs of a function are now the outputs of that inverse. And the outputs of the original function are now the inputs of the inverse. And we call this reverse mapping. So in mathematics, we had to communicate inverse. How do we go ahead and write and denote inverse functions? Well, for a function f, the inverse is denoted as f inverse. And it looks like an exponent that is -1. And you read this, you say this as f inverse, or the inverse of f, but everyone usually says f inverse. And if it's defined with an input, if f of a equals b, well then f inverse of b equals a. So just note that our x's and our y's switch. That's the main idea. Now, this follows is very, very logical that the domain and a range of an inverse function are going to switch. If x's become y's, right, my inputs, my domain, ends up becoming the outputs, the range, and the range, my outputs, end up becoming the inputs, or the domain. Graphs of a function and its inverse. Plain and simple, again, you're just going to switch your x and your y. And what happens for an inverse function is that we will be reflections over one another, over the graph of the identity function, which is f of x equals x, or h of x equals x. In x's and y's, it's y equals x. It's just the straight line with a slope of 1 and a y-intercept of 0. Okay? Also, h of x equals x is the identity function because its own inverse, or because h of x equals h inverse of x, which is equal to x. So let's go ahead and kind of look at some examples and put these ideas into practice. Example 1. The function f is shown in the table for -1 to 3, where x is an integer. Determine the input-output pairs for f inverse. Okay, and I'm going to go ahead and I'm just going to do this also in a table in the same format. So f inverse of x. You could also do this in a set of like ordered pairs, x, comma, y, but I think I'll just illustrate this point. So for a function and its inverse, x's and y's are going to switch. So I'm literally just going to switch these values. So now I have -8 gives me -1, -3 gives me 0, 1, sorry, not 1, 7 yields 1, 9 gives you 2, and 15 gives us 3. So again, inputs and outputs switch. Very, very simple. Let's go ahead and look at an example where we're given a function g composed of 2 line segments, and it's visually represented, and they say find g of 6, or indicate it's not defined. Well, here's g, 6 is my input, this is my input, here's 6, and g of 6, the output is equal to 8. So g of 6 equals 8. Not too complicated, it's a straightforward question. Now let's go ahead and rope in the inverse. Find the value of g inverse. of 6? Well, remember, with an inverse, x's become y's and y's become x's. So g inverse of 6 is now the x value. Well, in order to find this, I want to know what was the original x value that gave me 6. So essentially I'm solving for when is g of x equal to 6, right? Because if my output is 6, it will be the inverse's new input. So you could solve this by graphing. So I can go ahead and graph the line 6. There it is. And notice the intersection's right here. Okay, and so that x value is 5. Okay, so g inverse of 6 is equal to 5. C, find the value of g inverse of 9, or indicate that it is not defined. Okay, so again, I'm going to go ahead and I'm going to say, all right, where was g of x equal to 9? That will give me g inverse of 9. So the output 9, that's way up here. And notice that my function never is equal to 9. So in this case, it is not defined. Okay? Pretty straightforward. All right, I want you guys to use the same graph of g, and I want you to find g inverse of 2, or indicate that it is not defined. Pause me. I'll show you the answer here in a second. Okay, so hopefully you tried this one. Again, g inverse of 2, that means g of x is equal to 2. So our input for our original function was an output of 2. When was our original function have an output of 2? I went ahead and I graphed that here, and it looks like the functions intersect at x equals 3. So g inverse of 2 is equal to 3. And it's very important that you write this statement, because they asked you what g inverse of 2 is. You would not earn the point or be suffice to say this, g of x equals 2 at x equals 3. You need to communicate that the inverse, g inverse of 2 is equal to 3. All right, let's go ahead and look at some examples involving composition and multiple functions, along with this new idea of an inverse. Example, the functions h and k are shown in the table for selected values of x. They say, what is the value of h inverse of k of 4? All right, so we're going to go ahead and do composition. And again, the first thing that we want to do, so h inverse of k of 4, is I want to find what is k of 4. I got to find that value first. So again, this 4 is an x value, so I'm going to go to my x value 4, and I'm going to find what is the k value. So that's going to give me 2. Okay, so I now have h inverse of 2. And now I have to go ahead and find out what is h inverse of 2. And again, this is the same thing as saying, okay, when is h of x equal to 2? Okay, so what's the x value? That gives me an h value, that is 2. So we can go to our table here, and I have h is 2 here. Okay, and that output value is going to be 1. It's kind of like what we do normally, how we evaluate a table, but in reverse. So h inverse of 2. 2, here's an input. Well, for the original h function, it's an output. So I have an output of 2. Well, that original input value was 1. Okay. If you wanted to, another way to do this would be to make another table. So x and h inverse of x. And you could go ahead and list all of these ordered pairs again, right? So 2, 4, 1, 3, 1, 2, 3, 4. And then now h inverse of 2. So I go to my x value 2, and the output value is 1. So you could make your own table and switch those x, y values, or you can just do that process in reverse. Up to you. Okay, part B. What is the value of k inverse of h of 2? So again, what I'm going to do first is I'm going to go ahead and evaluate what is h of 2. h of 2. So I'm going to go to my table. Here's 2, and the h value gives us 4. So k inverse of 4. I got to find k inverse of 4. All right, well, it's an input here, but it was an output for the original k. So I want to go to my k values, and I want to find 4, and then the original input was 3. So our answer here is 3. There you go. Not too bad. Okay, I want you guys to go ahead, try this next practice problem. I'll show you the answers here in a moment. All right, hopefully you pause the video. Here are the solutions. H inverse of k of 1, well, k of 1 is equal to 3, and H inverse of 3, that's when our H value is 3, gives us 4. So first part is 4. Second example that we have here, we have k inverse of H of 3. H of 3 is 1. If we go to 3, we get 1. And then k inverse of 1, well, my k value is 1 at 2. Okay? So kind of doing that process in reverse, or remember, a question like this is essentially asking at what x value is k 1. All right. Okay. Here's another practice question. So now we are given a graph G, a piecewise function composed of 2 line segments for -6 to 6, and the function f is given in tabular form, a table of selected values. Go ahead and answer these questions. I'll just kind of do one example, do A, and I'll leave B and C for you guys. You guys have the tools. It's just 2 different forms. So let's look at the first one. G of f inverse of 0. We're going to go ahead and evaluate f inverse of 0 first. So it's important to note I'm using function f. F is the table, so I'm ignoring the graph. I don't even consider the graph. I'm using f, and f inverse of 0, right? So again, remember, this is kind of like saying f of x equals 0 at what x value. So I go to my f value, and that's 0 at the x value 3. So this is equal to g of 3. All right, and then I'm going to go ahead and evaluate. So now I go to my graph, G, and I find the input, right? This is an input. X is 3. It's right here. So what's the G value there? And that is 2. Answer, 2. There you go. Okay, go ahead. Please try these ones, and I'll show you the examples here in a moment. All right, here's the solution to B. On part B, this one's exactly like the first example that I did here, and not too bad. F inverse of -4, if we evaluate that, that has an input value of 5. So G of 5, and we can go to 5 and then evaluate that, and we get an output of 6. Okay, we get output of 6. And so that one's pretty straightforward, but C, I wanted to kind of help you through if you got stuck. So f of G inverse of 2. So again, here, this is saying, where is G of x equal to 2? So we can use our graph G, and I'm going to set it equal to 2, and this occurs at this x value, which is 3. So now I have f of 3, and you should be able to get your answer here, which is pretty simple and straightforward. 3 gives us 0, right? Okay, hey, that's it. Multiple forms, not too difficult. Okay, the AP exam loves to ask us questions about domain and range, and then also maximum and minimum values. So remember, domain and range of an inverse switch, right? So if I'm asked, what's the domain of f of m inverse? Well, then they're essentially asking, what is the range of m? Because x's and y's switch. And so our range of m here, that is going to be -5, -2, 1, and 3. Okay, and I just make a list of numbers. That's a 5. It's a 5. And I just use squiggly brackets on the end. Nothing too fancy. Example B, what is the range of m inverse? Well, they're essentially asking what's the domain of m. And our domain of m is -1, 0, 5, and 6. Okay? And there's our list. All right. C and D ask about minimum and maximum values of M inverse. So I'll first start by talking about what a max and a min is of a function. So like what if this was, what's the maximum value of M? Well, that would be the biggest M value or output value. So it'd be 3, okay? And what's the minimum value of M? Well, that would be -5. So the inverse, if they're asking about the values, that's essentially the largest x value. So what's the largest x value? And so we can look over here and we can easily see that it is 6. 6. What is the minimum value of M inverse? Well, what's the smallest x value for M? And that would be -1. So -1. Nothing too crazy. All right. Next practice problem. Please pause me. Try this example. We'll check our answers here in a second. All right, here we go. Here's the solutions to these questions about the inverse of G. This is a graphical representation, so you might have got thrown off a little bit. Students tend to struggle with what's the domain and range of a function given graphically, even though it's not too crazy or not too hard. What's the domain of G inverse? Well, that's essentially what's the range of G, and that's the y values. So what's your lowest y value for G? Well, that's going to be -7. And your maximum y value is 8. So here I used interval notation, -7 to 8, including those values because we have the endpoints. Okay, what's the range of G inverse? Well, that's the domain, the x values of your original function. And I used inequality notation here, so -6, right? My lowest x value is -6, and my biggest x value is a +6. Okay, inclusive. All right, and then minimum and maximum questions. I have a minimum value of G inverse. Well, that's the smallest x value, so -6 right here, -6. What's the biggest x value? Well, that's +6. Okay, so not too difficult. All right, last example I have for you is a graphical example, and they give us a function here. They say the graph of the function f is shown in the figure, graph f inverse of x on the same xy plane. So what I want to note is that I have the function here y equals x. That is this dashed line that goes through here. This is the identity function, where if I switch these x and y values, I get the same exact function. And so our inverses are going to reflect. You can imagine a mirror. So imagine a mirror. Take this picture and flip it over. That's what your function's going to look like. As well as anytime your functions intersect, they should intersect on that line where the x and the y values are the same. So let me go ahead and show you how we're going to graph inverses. You can go ahead and identify the points. And then we're going to switch our points. So I'm going to take my first point here. It looks like it is -8, 8. So -8, 8. And sometimes you can make a table. Sometimes it's easier to organize this in a table. -8, 8. And then my second point here is -5, 1. And then my third point is 4, -2. So the inverse is going to be these same points, but switched. So 8, -8, 1, -5, -2, 4. So these are your new points. And we can go ahead and graph these. So 8, -8. Okay, 1, -5. And then we have -2, +4. So there's our points. Notice I do have to connect these points. And so we're going to go ahead and draw these connections. And it's best just to take note of kind of like what the curvature is. It's not connect the dots. It's not straight lines. Well, one of them is. But notice how from my first 2 points, it's kind of curved. Okay, and so it's opening. So I'm going to draw a little curve. And again, it should mirror this side. It should mirror that side. And then these next 2 points, they're a straight line. So this one's relatively straightforward. Okay, And there you have it. And then notice, too, this inverse, hey, they touch, they intersect directly on that line. So there you go. Okay. Last practice problem for you here. Please go ahead. I want you to graph the inverse on the same xy plane. Take note of your points. I want you to switch the points and then graph them. Again, identify points, switch your points, and then graph them. Okay? All right. I'll go ahead and show my work here in a second, but pause me. All right, so hopefully you went ahead and identified your points. I have them up here in red, and then I switched my points so you can see them here in blue, and I graphed these points. One thing that's hard for students sometimes is they'll connect the wrong points. So it's kind of nice to make note of what points go in which order, because those are the points that you're going to graph. Okay, so and some people put like a number, like they might put a little number 1 here, a little number 2, just to identify like the order. Okay, and then another thing too is if we're covering great distances, it's hard sometimes to draw a straight line, so you don't want to get an arc in this. So you maybe want to have like a trusty straight edge, like a ruler, or you can use like an ID card in your wallet if you have a wallet. So I can go ahead and I can put these, together. And then I can draw a straight line. All right, so there we go. And then these 2 points, like that. Okay, and then these 2 points, lastly. If I can graph them. There we go. All right, so there's our function, and here's the idea is that it should look like a mirror image if you fold this over onto the other side. That's what it should look like. All right, and then also any intersections should happen on this. So this doesn't look right. Why is this not looking right? What's going on? -4, -2, -4. Oh, this point should be down 2. See, that's why knowing intersections should happen on the line is helpful. -4, -2. It should be down here. So let's go ahead. Let's double check that. Okay, there we go. That looks better because now my function's intersecting on my identity function line, and then drop in my ruler, and then we'll go ahead and connect these points. And that looks better. That looks more like a mirror, okay? All right, so that does it for inverse functions. Here's the idea with inverse functions is that outputs become inputs and inputs become outputs. That's the definition of an inverse. Domain and range switch. And if you have a function f of x, its inverse is going to be denoted as f inverse of x. Catch you in the next video. Give it a thumbs up. Support my YouTube career. I'll see you later. Bye.